Okay, welcome all to September webinar, Clouds Unification, Telco domain. This time the webinar is really focused on a specific, I would say, technical topic. So I expect that we will take less time compared to other webinars. I'm going mainly to assess the case of cloud unification on the telco domain, and I'll be following some sort of a methodology. I will start first with the definition and classification of the cloud types at telco environment, and then we will take a look on a typical cloud stack to understand what's the definition of unification mapped to the ingredients of the cloud stacks. Also, I will cover the trended terms like multi-cloud and hybrid cloud, and also we will assess to get together the motivations for the unification. I'll also mention a principle called unification levels that will help us to understand how actually we apply the concept of unification on the existing cloud stacks. But before I do that, let me just quickly introduce myself. My name is Karim Rabia. I'm currently a senior telco architect at Red Hat, but my main technical, I would say, background comes from the telecom domain, from the mobility specifically, being an ex-consultant in the packet core and the APC, and like starting maybe I would say for the last 7 years, I've been focusing on the cloud technologies and orchestration and automation. I had previous roles in multiple vendors and system integrators and operators. And also, in addition to that, I have some, I would say, contribution with some community groups like ETNFV, CNTT, some work with ITU as well, and OpenNFV. So let's start, but before we do that, just to let you know, I will stop after each section to take questions. You can use the Q&A utility. I'll be looking to that after each set of slides or after each section. Uh, let's start, and thanks again for attending. If you have any problem viewing me or viewing the slides or listening to the audio, please let me know. So we start with some assessment for the existing cloud or the clouds that most probably you will meet in a CSP environment. And CSP is the communication service provider, which maps to the telcos, which maps to these service providers like mobile operators and fixed service operators. So let me use the laser. So in a CSP environment, there are some typical cloud stacks that you usually meet. One of them and the most famous is the IT cloud. Okay. And the IT cloud, usually it is a form of a private cloud that is being built internally in a mobile operator environment, mainly to host IT applications. And whether it is an IT application or a non-IT application, that's some sort of an internal classification done by the operator itself. For example, this kind of IT cloud can host IT applications related to, for example, some OS systems, Active Directories, some CRM, customer relationship management systems, some internet application at the mobile operator environment. So these are actually the applications that lies under the term IT applications. So it's one of the most well established private clouds. It has been there since a while. People working there, they usually have very good experience with virtualization and the cloudification in general, and the techniques have been there since the 70s. And that's why it's really one of the most mature cloud stacks in any telco environment. I would say the previous generation, the existing generation, was all based on VMware, but now there are many variants of the IT cloud. The other cloud that you may meet at a CSP environment, and it also maps to some sort of a direction at the mobile operators to offer enterprise service, which is the enterprise cloud. Or we can call it like the public cloud service offered by the operator itself. And this is usually a cloud that hosts what we call the B2B service or business to business. And it's like the same concept what the hyperscalers are doing, like AWS and Google and Azure, for example, but on the scale of the mobile operator. So in that case, the mobile operator itself, uh, the operator made a cloud to offer enterprise service to his enterprise customers. What are these services? These are the typical infrastructure as a service, platform as a service, or software as a service. Infrastructure as a service, where the enterprise can just host their workloads, having like VMs or virtual machines or resources from the enterprise cloud, and SaaS to reach a level where the cloud can offer like a full software to be leased to the enterprise on demand, like something like Salesforce, something like Microsoft Office, these kind of things that actually consumed on a cloud delivery model. The third type that you may meet at telco at a telcos or CSP, which is the telco cloud. And telco cloud started to emerge with the evolution of the NFV, the network functions virtualization, and that was starting from 2012, but really it got a good momentum starting from 2015. So from 2015, you we started to see the rise of telco clouds having a certain cloud deployment mapped to ITSI NFV reference architecture. So it was very aligned to the standards coming from ITSI, European Telecommunication Standardization Institute. And the primary goal for this cloud is to host the telco VNFs, the telco virtual network functions, and serving the consumer market, the enterprise, whatever. But these are like the main network functions that construct the telco ecosystem, like the core network, mobile core, fixed core, some part of the RAN, firewalls, these kind of things. The model was typically infrastructure as a service. It was relying mainly on, for example, OpenStack and VMware stuff to provide virtual machines to network functions. But recently, the model is now has evolved to also provide container as a service and platform as a service. Why? Because the network functions now have started to be containerized. So Telco Cloud now is evolving to provide CaaS and PaaS. Other than that, you may find xCloud, any kind of cloud, because there are multiple private clouds that may exist in different administrative domains. For example, the charging team made some sort of a cloud made by the transport team. So some mini cloud stacks may also reside on the CSP environment. Lately, also we have seen the rise of having an on-prem public cloud stacks. For example, the case of Outpost and Wavelength of AWS with Verizon. Also, we saw recently Outpost, uh, Azure, and it's a lot. So also there are now some on-prem public cloud stacks that exist on a CSP environment. So regardless if this can be classified as telco or enterprise, it's an X cloud. So there are many other stacks that exist. So having said that, I hope that now that the picture is clear that any normal mobile operator can actually have the case where he find like there are like 3 or 4 cloud stacks running uh, at the premises of the mobile operator. Each cloud has its own resources, delivery model, fault management, performance management, FCAPS, orchestration, whatever. And this is one of the compelling reasons at a certain stage to go for unification. We will see that in the next slides. But before we do that, let's just agree on the definition of cloud unification, because you may find multiple definitions in multiple contexts on the internet. So I chose one, and it's simple, so that's why I like it. So cloud unification is a term that is commonly used to refer to the configuration of multiple cloud stacks in the same enterprise under one administrative umbrella. So if you map this definition to the last slide, so this may map to a certain direction or initiative to configuration of these cloud stacks under the same enterprise, which is the mobile operator, but the most important thing under one administrative umbrella. And that administrative umbrella, we will see it mapped to the unification level that we will talk about in the next slides. So it can be like these cloud stacks having a unified orchestration, maybe a unified controllers, maybe a unified uh, operational models, maybe unified hardware resources. So an administrative umbrella, it's a broad term that actually maps to these different use cases. So that was the case at the CSP's environment when it comes to cloud's existence. And this is actually the definition of cloud unification. Before I go and talk about the cloud stack ingredients, because that's an important aspect, is there any question on the last two slides on the introduction? So I'll allow you like 2 minutes to write questions, if any. If not, we can continue. Okay, very good. So let's continue. Let's now, I would say, agree on what a cloud stack should look like. Because before we talk about unification, we need to understand what are the ingredients of a typical cloud. So we start with the green part, and that's, I gave it multiple words to describe that part. You can call it cloud infrastructure or infrastructure hardware. Sometimes on the NFV terminology, they use the term NFVI, which is the NFV infrastructure, or sometimes they say NFV infrastructure hardware part because there is a software part of the NFVI. But anyway, these are the I would say the components that construct any kind of infrastructure that actually host cloud application. So there are three main ingredients of any hardware infrastructure or cloud infrastructure: the compute, the storage, and the network. So the compute is actually the computational power provided by the servers. So this term compute maps to the servers that host the application and host hypervisor and host the operating system. And usually the term compute maps to the CPU power and the RAM. Okay, so it's CPU and memory. That can actually span across one DC, multiple DCs, tens of servers, hundreds of servers, that at the end there is a compute or computational power. Storage, that's the storage capabilities of the infrastructure. It maps to local capabilities of the compute servers, external storage clusters, SANs, this kind of dedicated storage solution, and the center fabric or the network that maps to the networking capabilities of the infrastructure, that maps to the spine leaf switches, data center gateway, any kind of networking infrastructure exists in data center and contributing to the cloud infrastructure. On top of that, and that's a typical layer, which is actually the software or the cloud operating system, or sometimes in a marketing term, we call it cloud offering, or the NFVI software part. Usually, this maps at the end to what kind of capabilities provided by that operating system. So there you can see like hypervisors. You can see capabilities for software-defined networking. For example, this kind of virtual routers, virtual switches, this kind of software part. Uh, in that layer, you start to provide services or cloud services. For example, you can provide infrastructure as a service, and that maps, for example, to the hypervisor hosting virtual machines. You can start to provide CaaS, container on bare metal or container on hypervisor. You can start to provide PaaS, platform as a service, either some sort of complementary service or an environment for development. You can start to provide multiple services, and that's the operating system. But that kind of infrastructure, that kind of operating system or software needs some sort of manager or brain to govern their function. And that comes the term controllers. So controllers actually can map to solutions like OpenStack, can map to solutions like SDN controllers, can map to any kind of controller for infrastructure, for example, something that manager for the fabric. So any kind of solution that have, I would say, the operating system part or the hardware part require controllers. So controllers is the main brick in any cloud stack. Uh, on top of that, there are some stacks for orchestration. So there are orchestration for the resources, orchestration for the application. You can find orchestration many things. For example, if you are deploying Kubernetes, providing CaaS and potentially PaaS, that can be an orchestrator. If you are having an NFV stack like Telco Cloud, you can have the NFVO. So usually there is an orchestration as part of the stack. Operational tools, any kind of cloud has some sort of corresponding stack that provide the FCAPs, for example, the fault management, configuration management, accounting, performance management, some security stuff, maybe providing RCA, providing lifecycle management. So there is always a stack of operational tools coupled with any cloud. And then digital user experience, this is actually a layer that allows users to consume services. The same way you go to AWS and then you click on the service that you want, and then you take the virtual machine and the resources and you pay for it. Most of the clouds have this kind of digital user experience, some sort of portal that you can go as an administrator or as a user to start consuming the service. This kind of cloud, at that level, usually cloud professionals stop. They don't care a lot about the applications, but to see the full picture, you have to acknowledge that any cloud hosts application. So these applications can vary from extreme 5G core telco stuff, okay, to IT applications, to some in-house applications based on development, and even a room for third party to develop their own applications. So applications even may vary according uh, to the domain and the cloud characteristics. In reality, if you remember the first slide where we showed the types of clouds, in reality, you will find in any CSP environment multiple clouds, but they don't all have the full stack or cloud stack ingredients. Some of them, for example, like Cloud One, they may have like good stack, good controllers, full operational tools, but for example, they don't have orchestration stack. Or maybe they are missing a digital user experience. There is no nice digital experience to consume service. Some others, like Cloud 2, for example, they have good digital experience, but they don't provide PaaS or CaaS. Some clouds, they don't have they have like minor or monolithic applications. They have like very low footprint for applications, and for example, they lack a lot on the management stack. So most probably, when you start to assess the clouds based on that diagram, you will find that clouds vary in terms of capabilities, in terms of components, and in terms of ingredients. So you end up with some sort of a hybrid setup of multiple clouds having different ingredients. This is an important slide. So I hope you have already digested the information. If you have any questions, now it's the right time before we talk about the unification. I see some questions, so I will go to see the questions and then we come back. Okay, I have one question. Uh, how possible is to incorporate cloud stack, say AWS, with on-prem cloud of CSP? That's a question. And then the other one, how far the security or compliance is done today? And that's another question. So for the first question, there are actually many flavors of such kind of cooperation. Okay. One of them, that the hyperscale like AWS is actually deploying their own services on-prem with the CSP existing data centers. So like the wavelengths, the cooperation between, for example, AWS and Verizon. AWS has deployed their clusters, stacks, and services on-prem at Verizon premises. So this is a kind of cooperation, and this one somehow it complies to many security compliances because you don't put the information of your customer database on a public cloud. It's actually on-prem. There is another way of cooperation where actually operators can rely on AWS or hyperscalers or public cloud services to host some applications, like for example, BSS, OSS, PCRF, because they don't want to invest in a big infrastructure or huge infrastructure at the CSP. And in that case, it differs because some countries have strict regulations according what kind of application can be hosted in the public cloud, what kind of customer information can be there in public cloud. So, for example, in the region where I work, mainly on the Gulf and the Middle East, it's a little bit difficult to have any kind of customer information hosted outside the premises of the country. So that's why you find that hyperscalers, they always try to put data centers in many regions close to the main customers to avoid this kind of compliance issues. So second question about how far security or compliance is done today. As I told you, it differs according to each country. Most probably in Middle East and in the Gulf specifically, hyperscalers, they come to the operator and they deploy their own stacks at the operator premises. This is the way that it is working currently. Uh, any other questions? Good. So the case is as is. We have multiple cloud stacks. So what are the motivations? I mean, why CSPs are eager to do such unification, and why actually it's a trending term. I mean, if you search on Google or even if you are working on telco environments, you'll all see this term everywhere, cloud unification. So the first motivation, and these are all coming from my experience working with such exercises, the efficient resources utilization. There are some scenarios where you find like Cloud X, for example, it's 90% utilized, it's very exhausted, and there is really a need for more resources to host more applications. And Cloud Y, adjacent Cloud Y, is actually on a 10% utilization, and resources are available but cannot be consumed by Cloud X. So from resources efficiency and resource utilization efficiency, unification will guarantee that resources across the whole infrastructure will be uniformly or efficiently utilized. Second thing, that from CapEx and OpEx perspective, from CapEx, you are now in need to expand Cloud X because it is fully utilized. But there's Cloud Y that actually you can use it, but because of the isolation of both stacks, you need now to start put more money to purchase more servers for Cloud X. So having this kind of unification actually reduce the CapEx requirements and the CapEx spending. OpEx reduction, because whenever you have multiple clouds, most probably you will have multiple operations and potentially multiple managed services, and the federation of these kind of cloud stacks can give you like good OpEx deal or having a unified or one operational or managed service provider. So it contributes heavily to the CapEx and OpEx reduction. Second thing, that you are looking to go for a common framework of capabilities. As I showed you in the last slide, you will find in the reality that CloudX has a very good, for example, capability in DevOps, but Cloud Y doesn't have any kind of CI/CD or DevOps stuff. Where Cloud Z has a very good automation workflows. Work so every cloud has its own unique capability or own unique, I'd say, yeah, advanced capability exposed to the enterprise. So there is always a good motivation that to generalize this kind of advanced capabilities across all clouds. So for example, it usually comes like that. For example, IT, they have very good application dev experience and DevOps. So unifying the IT with Telco, for example, will make us enforcing the DevOps framework across the unified cloud or across the two clouds. So this is one of the main triggers for unification. Third thing is attractive commercials, and that's for sure the commercials are the main thing with the telcos, that you have multiple clouds. This means that it might be multiple budget cycles, multiple suppliers, so you don't get nice deals. But if you have like one unified cloud with one unified infrastructure, then you will get a very nice commercial deals with whoever's supplying this infrastructure. So this is always a motivation coming from procurement that let's unify the clouds to guarantee a one budget cycle purchase and a guarantee a good attractive deal. The fourth point, it's actually the efficient service delivery and lifecycle management. If you have isolated clouds, then apparently you will consume services in an isolated fashion. For example, you take service from Cloud X. If you can monetize it, you just monetize it, and you take a service from Cloud Y and you sell it to another customer. But there is no framework to consume a certain service that spans across two clouds. For example, you take a certain infrastructure as a service from an IT VMware stack plus a security service in a telco cloud on over OpenStack. So you do these together and you bundle it and you sell it to one customer. So if you don't have a unified framework for these two, you cannot provide such service. You will still have to provide each service separately, like the infrastructure as a service from that cloud, and then separately the security from the other cloud. Fifth one, when there is an intention or a strategy to go for open source adoption, for example. Yes, let's say you have a cloud X that's based on some vendor specific cloud, and the other one is based, for example, on open source operating system, cloud operating system. So there's a strategy to go for open source adoption. So you try to unify open source cloud on the two. It's not that common, but we saw it especially in 2018, 17. That was, I would say, the way of thinking because of the rise of the open source solution by that time, in the telco specifically. Six, which is very common, that this shouldn't be like, or this should not. I mean, the motivation shouldn't be only a technical motivation. Sometimes, and actually in most of the cases, it comes from organizational change. For example, some two departments that used to have two separate clouds, they merged together under one director or one GM or one VP or whatever. So this kind of organizational change, sometimes as a consequence, it enforces the clouds merge or the cloud unification. So that's why there's you can do, like, for example, think of it like, okay, now department has merged, now teams has merged, now it's time to talk about unifying the operational model, then it makes sense to do cloud unification. These are like the main six motivations. For sure, maybe you find other motivation, but these are like the six main stuff that actually I found it during my previous work at this kind of engagements. Any question? I see one question, so let me reply to it. Okay, one question. The question is it wise to go with single vendor providing all cloud components presented in cloud stack slide, or it is better to go with multiple vendors providing different components. For example, NFVI from vendor one, while compute and storage from another vendor. So let me answer that. This has been like a very common question for the last 7 years. So it there is no one solution that fits all. We always start by that sentence, but here, yeah, it makes sense because, for example, if there is an operator that relies heavily on a certain vendor or a certain partner, strategic partner that have used to provide like core, radio, whatever, then it makes sense that if he goes for virtualization or cloudification, that he relies on the same vendor because the idea itself is not just like bringing more and more vendors and building a hybrid cloud or a mix and match or multi-vendor cloud. The idea is actually how to reach or how to achieve my business targets. So if your partner, the supplier, is capable of building the full stack and delivering the value to you, then that's fine. But having multiple vendors will give you for sure the advantage of selecting the best of breed at each layer. For example, you will get the best storage solution in the market, with the best compute solution in the market, the best cloud operating system, the best container orchestration solution, then you will be sure that you elected the best solutions. Okay. But the challenge is actually how you integrate all these components together. So the perfect match that if you find a system integrator that's actually have experience doing all these stack together, components together, then that's the perfect match. Then you rely on that system integrator and you deliver. But at the end, it's all about TCO and analysis. It's all about achieving business targets and business goals. So both ways are there. You do your calculations. If you have the luxury to select multiple vendors for multiple components, have them integrated, and make sure that will make you reach your goals, then go for it. So that one I will mark it complete. There's a question about the level of unification on the cloud administration or operational task, end-to-end monitoring events. I'll just defer that question to the unification slides, and I will get back to it. So let's go back to the slides. I hope till now the sequence is okay, the informations are clear. May I just get your quick feedback? Are you okay with the content? Are you catching the logic, or there are things that's not clear? Okay, so we continue. So speaking about cloud unification, whenever you talk about cloud unification, there are some, I would say, very close terms or adjacent terms that being always used, which is actually the multi-cloud and the hybrid cloud. So let's assess these two terms and see how they contribute to the cloud unification. Um, I usually like to start my slides with a reference or with something that gives you the indication on how the community is thinking of that topic. So I quoted that from one of the Gartner's publications. Maybe it's not a new one, but it's like the last 3, 4 years. So they're saying that most organizations adopt a multi-cloud strategy out of desire to avoid vendor lock-in or take advantage of the best-of-breed solutions. We expect that most organizations will continue to willfully pursue this approach. So it seems that there is a trend to adopt something called multi-cloud, and the motivation is to avoid the vendor lock, or to having multiple clouds. This means that you can get the best of breed solutions out of each cloud. But what is actually a multi-cloud, and also what is a hybrid cloud? This is the next slide. So there are many definitions, many terms defining multi-cloud and hybrid cloud. So I chose and I actually adopt that simple one. So multiple clouds, even from the naming itself, is actually where the CSP or the enterprise keeps different cloud stacks, separate cloud stacks, private, public, two privates, whatever, but separate cloud stacks. And each one has a distinct service cloud portfolio. Each one is providing its own services portfolio. And there's not any kind of interoperability or service lifecycle management between these two clouds. So this is, for example, maps to the first slide that I did, that you have like multiple cloud stacks, but each one is delivering efficiently a certain service. And you keep this kind of setup. Why? Because if you refer to the last slide, to avoid vendor lock-in, so you'll have like multiple clouds from different vendors, and to pick the best capabilities and best solutions and best exposed capability from each cloud, and hopefully you can monetize that and sell it to the end user. So this is the multi-cloud, okay? In a very simple term. I'm sure you can find more complicated stuff and descriptions. For example, someone is mandating that it should be one private and one public, or private and public, but from my experience, it's still a cloud. So if you have multiple cloud stacks, even if they're all private, then that's a multi-cloud scenario. A hybrid cloud is a little bit different because you still have the cloud stacks, but you have the capability, as you see from the diagram, to consume services from both clouds together. For example, if we take the multi-cloud and we say that the green user is actually consuming an infrastructure service like hosting service, and the yellow one or the orange one is hosting a firewall service or security. So these are two different products with two different billings, with two different service delivery models. But if you have the hybrid cloud and you have some sort of solution that can enable you to consume service from the clouds and bundle that in a certain product or a certain unified service, then the blue customer will purchase an offer called Gold Offer or Gold Cloud Service. And this Gold Cloud Service or the bundled product can consume at the same time the infrastructure as a service from the cloud plus the security service from the cloud, the Orange Cloud. So that means that you can now combine these two capabilities or these two exposed services in one product or one bundle, and you monetize it and you sell it to the end user. So this is the difference between a multi-cloud and hybrid cloud in a very simple term. And I like simplicity, so it's not just being simple, but really that's why I adopt in my work, and actually that's what I've seen as part of my experience working with the mobile operators with different cloud stacks. Any question about the concept of multi-cloud and hybrid cloud? I see two questions. I'll just go see them. Okay, so just a question about the multi-cloud. I'm going to repeat that. Multi-cloud is a very straightforward, even from the term itself, it's multi-cloud. So you have like distinct cloud stacks. They are not integrated. They are not related to each other. So whenever you need consume a service, you need a service from certain cloud, you just consume it separately. So you, for example, you have a green cloud and an orange cloud. The green cloud is giving green services, the orange cloud giving orange services. So you sell two services even internally or to the end user separately. There is no way to do a bundling or a composite service lifecycle management between the green and the orange. Hybrid is different, where you have the capability to fulfill a composite service or a certain product or bundle leveraging the two clouds together. So that's the multi and that's the hybrid cloud. And that's a very trending topic at the CSPs currently. Okay, so the last section in that webinar, and I told you I wanted that webinar to be very focusing on a certain topic for us to all to understand the concepts around it. So, and that hits one of the questions that were asked in the chat about how you do the unification. So one of the most common ways of doing unification is actually doing the unification on the orchestration level. Does this look like a unification? Yes. Unification doesn't mean that you will have to collapse the hardware together, right? It doesn't mean that you need to have like one controller like OpenStack doing everything on all clouds. You can do that by introducing a new layer called multi-cloud orchestration. Multi-cloud orchestration will simply allow you to have the case of hybrid cloud so that you can consume services from different clouds. And at the end, this is what you want, right? You want the agility to deliver services and composite services. So you introduce a layer called multi-cloud orchestration, and most of the suppliers, cloud suppliers, they have some sort of solution that can talk to multiple southbound controllers. It's a least destructive solution because there is no migration. I mean, each cloud stays calmly in their premises. The only thing that it's not that easy to achieve the service lifecycle management across multiple clouds, because this required that this guy, the multi-cloud orchestration, understand how to talk with cloud green and black and blue, and that can be VMware, that can be OpenStack, that can be Azure, that can be anything. So this should be a powerful multi-cloud orchestration. Little bit hectic operations because still each cloud will have its own operations. So we didn't do much from operational perspective. Each cloud stay as it is. So you'll have like here, for example, you have three teams doing the operations. One of the most common challenges that we have in the orchestration domain, and I have explored that personally, that whenever you introduce a certain orchestrator on an existing environment, there should be some sort of capabilities of discovery. The new orchestrator must discover the existing environment. And this is a tough operation, and not all orchestrators and cloud support that. So there are some manual works to be done. So that's why, for example, we always say that the orchestrator is better to be introduced at the beginning in a greenfield environment, because when you do that at a later stage, you need discover. Discovery will bring, I would say, some difficulties and some challenges. Some other, I would say, techniques that you go a little bit deeper and you do unification on the orchestration and the operational tool and on the controllers level. This means that you will migrate, for example, here you migrated the black cloud. You took the application of the black cloud and you migrated that to the green cloud. And you took the hardware infrastructure, the servers of the black, and you added that to the existing green cloud. It's disruptive because you will have to migrate the black application to the green cloud. So you will have this kind of migration for application from an existing cloud to another. This is not easy because maybe this black applications are not certified on the green cloud OS. So you need to do recertification for these applications to be migrated. So it's not easy. Also, the hardware infrastructure in telcos in general, it is recommended to have a uniform servers or hardware servers for the cloud. For example, if you are adopting a certain server model like profile, like 26 CPU, certain board or Intel board, it's not recommended that a VNF spans across two different hardware models. So if you introduce a new hardware model, for example, an 18 CPU server, it's not recommended that the VNF spans across two servers or two hardware profiles. That's why some operators think that whenever we introduce a new hardware like the white one here, they put it in a host aggregate. Host aggregate is a term in OpenStack, but you can use it as a general term that actually say that these server profiles or hardware profiles will be somehow isolated. And whenever you want to onboard a certain application, you choose either you put it on the green or you put it on the white. So you start now to segregate your clouds. But why you do that? Because Sometimes, as I told you, it's not recommended that a certain application spans across two hardware profiles. And sometimes in Telco, unfortunately, some network functions require a specific hardware profile. So that's why you start to do this host aggregates to make sure that you onboard this application to this hardware profile or the white one. So if we see the remarks here, we find some advantages. For example, when you do this kind of cloud unification on the controller level and the cloud OS, you start to have an ease of operation because at the end it's one cloud at the end. Uh, you start to have a unified northbound integration. For example, in the last slide, you see each cloud has its own northbound integration to the northbound systems. But once you do that, you start to have one northbound integration, so it's less integration points. The network service lifecycle management across multiple VNFs from different vendors, now it is fine because at the end it's one cloud. Most probably you start to enjoy a unified CI/CD design environment. Again, it's one orchestrator, one cloud, then why not? You have the possibility to isolate VNFs for performance reason or security because you have a host aggregates. So you can say that this VNF should go to this host aggregate. It's not a nice practice, but it is common in telco. As I told you, this may require certification for the migrated application on the new cloud OS. So in the old days, the applications here were running on a certain cloud operating system. So if you enforce this application to go to the green one, then you need to do a process called certification to make sure that these applications work on the cloud OS, the green one. Fortunately, if this has been done in some offshore lab with the vendor, then it'll be fine. If not, you'll have to do it on the premises of the operator. Host aggregates do or does aggregates do cloud fragmentation, and this is not a common practice. When you start to fragment your hardware to different profiles, it is a practice in telco, but at the end it fragments and it causes cloud fragmentations. Last one, and you may see this term one cloud. One cloud is a little bit aggressive, where you just merge everything. Okay, you migrate the applications, you unify the hardware infrastructure, you don't do host aggregates and everything. The difference between that one and the previous one, that this one is an efficient resource utilization because there is no host aggregates, there is no segregation for the resources. So now they are all one unified resource domain. You can consume resources. Uh, I mean, using the cloud techniques. I mean, there is no limitations on how resources are being distributed across the infrastructure. Uh, This is a little bit aggressive, but if you start to see the community out there thinking, the term one cloud or unified cloud is there. So eventually, because nowadays with the evolution bringing cloud native application, this kind of thing, the differences between the applications have really become very minor. I mean, in the old days, 5 years back, IT applications was completely different from telecom network functions. But now after adopting containers, after adopting the cloud native techniques, most of the applications now become very similar, or they are on the way to be that. So once we all go to this kind of unified or common practice cloud native solutions or designs, in that case, it will really make sense to have a unified cloud because there will be no compelling reason to have a dedicated cloud for a dedicated kind of applications. The term IT, telco, enterprise will not really make sense by that time. So this is what we want to achieve. Let me stop here and take questions. We still have 6 minutes. Okay, there's one question. I'll just leave the others. I will reply that offline just to keep the pace that we are following this. Do you mean that multi-cloud it can only be between different hyperscalers for different functions? No, I didn't say multi-cloud for hyperscalers only. An operator can have a multi-cloud having two private clouds, for example, IT and telco, both delivering services. So that's the first point. Multi-cloud is not it's not a term that is strictly coupled with hyperscalers. While for hyperscalers, it only needs to be within the hyperscaler vendor. No, no, no. It can be private, public, private, private, public, public. There is no coupling with hyperscalers. So I answer this one. Okay. I have 5 minutes, so I will take the rest of the questions offline. Usually I do that on LinkedIn. So let's just conclude the session and see the main takeaways. And here's our guy. So cloud unification, it's one of the really trending terms and tactics that telcos are doing now. And it is usually coupled with some sort of strategic assessment or strategic roadmap. So if you are working on a telco vendor or telco operator, mobile operator, you must have heard about this term. And I hope with these kind of information and content, you are now somehow confident to start conducting a discussion and an assessment about the same topic. I just brought 3 types of unification levels, but there are many types and options and scenarios for unification. And you can unify operational tools if possible, the service lifecycle management. You can have unified design environment for multiple runtime environments. So there are many flavors. So there is no one solution that fits all. That I just wrote some highlights about the, I would say, uh, the common practice that we see in the market currently. You don't have really to collapse everything. Maybe you don't have to migrate. The cost is high. There is no point in doing that. So multi-cloud orchestration is a trending practice because you get one abstraction layer that actually abstract all the clouds under that. And then that abstraction layer expose services, multi-cloud services or hybrid cloud services to northbound systems. So it makes sense to do that. And it looks like an easy step. Okay, and as I told you, there are many vendors are providing this kind of thing. Just search in Google about multi-cloud orchestration. Hybrid cloud, multi-cloud. I hope now you are comfortable with these terms. They are really very strategic stuff that's being discussed by most of the telcos now. Shall we keep the multi-cloud? Shall we have one orchestrator enabling us to do a hybrid cloud? Shall we merge them all? So these are like the questions that being asked and discussed at the mobile operators environments. So that's it. That was the 1 hour. I hope that was not a heavy topic, but it is really one of the trending stuff, and I meant to cover it because there are many scattered information everywhere on the internet, and you don't find a lot of content about that specific topic. I hope that was informative, and I will take the questions that I haven't responded due to the time, and I will respond to that offline. We still have 2 minutes. If you have any comments or any questions, feel free to enclose it, and I will have a look to it. Okay, thank you all, and I hope, yeah, again, you that was informative. Any questions? I think you all know my LinkedIn profile. Just feel free to ask me, and I will share the presentation and I will upload the video on YouTube. Thanks a lot. I really appreciate your attendance and hope to see you next month.